This presentation is a fluid mechanics project. My name is Zoe Elliott. This was done for Chemi 305 for Dr. Razor Fadowsi at the New Mexico State University Chemical Engineering Department. The purpose of this project was to use course content in a real-life application where we were given a schematic and flow rates, and we got to choose the diameters and the pumps, the fittings, valves, elbows, whatnot, and come up with a budget for how much all of it would cost. For this project, I chose to use copper because it has low roughness and ease of availability. I chose 2 different diameters to maximize efficiency since flow rates were all varied. I assumed density of water to be 1,000 kilograms per meter cubed and viscosity to be 1.13 kilograms meter seconds. Using these values and the flow rates required, I was able to calculate the Reynolds number, which was turbulent for all of the pipes. With Reynolds numbers and roughness factors, I was able to determine friction factors using the Moody chart. After obtaining the friction factor, I calculated head loss associated with each of the pipes and elbows and valves used. I was then able to use all of the pieces of information to calculate the pressure the pump would need to produce. I then looked up a pump and realized I needed to change my units to what pumps are sold in, which for the one I chose was gallons per hour. I then made a table with all of the prices of the items I needed and multiplied by how many or how much of each item I needed to come up with for a proposed budget. Here are my Moody charts. You can see I went up from the Reynolds number and over using the roughness factor to go over to find the friction factor for warehouse, garden, bathroom, and kitchen. Calculations. All right, so here is where I chose my diameters. They're all sold in inches, and I used the information given by the company for the inside diameter of each pipe. I then calculated the areas and used that to calculate the velocities with the flow rates. All right, Reynolds numbers. So here are my Reynolds numbers for the garden, warehouse, kitchen, bathroom. Also the copper roughness used, which was 1.5 times 10 to the negative 6th. I also put right here my friction factors for garden, warehouse, kitchen, and bathroom. All right, rest of the calculations. I put my pressure loss for each one as well as my head loss for each one, and then calculated the work needed to be produced by the pump, and I then converted it, which turned out to be pretty high. It was 3,899 gallons per hour. But if you think about it, I guess hour is a long time. So here's my budget and total price of each unit of everything with the extended price, so how much I would need. The required flow rates were pretty high. This could potentially be decreased with diameter being changed or using different valves with different curves to reduce the KL value for HL. There's other less expensive composite materials that could also be used that I didn't choose because I didn't know where to get them. I think if I were to do this over again, I would do it with a team and compare and contrast what their thoughts would be to get a more effective thing. Here are my references. I used multiple websites and the book Fluid Mechanics and Applications by Singal and Simbala. Thank you.